Light somehow knows where it's going to ahead of time. It sort of operates in reverse time ordering. People have been trying to explain this for many, many years. For example, if you're looking at this fish in the water, you're staying over the water, the image of the fish is going to get projected up to the water, up to the surface of the water, and then off to your eye on an angle there. And it does that because of the relative speed that the light can go through the water versus the air. So it knows that if it's a lot slower through the water, it knows that, well, if you're going to be standing over here, if it can go up here, it'll be a lot faster than going here. But how does light know that? How does it know where it's going to after it hits the surface of the water, right? That's called the rule of least action. And that's really hard to explain. Now, there's a guy named Richard Feynman. I don't know if you heard about him. He's got something called the Feynman path integral. He tries to explain it. And the way he describes it, he says, he says that somehow light builds up a past history of all the potential pathways it can take along the way between an emission and absorption. And he says upon the time of absorption, it can look back at this past history that the universe somehow has collected and determine this best optimal pathway to take, the one that follows the rule of least action.